This is Yashfa Tanveer from Pakistan. I'm a PhD scholar from ComStats Islamabad, and this work was carried out in Buenos Aires, Argentina, through the 6-month internship program funded by Higher Education Commission Pakistan. And the work involved the rhizobacteria-mediated green synthesis of zinc oxide nanoparticles, which enhances wheat growth and drought tolerance. We all know that drought is a major issue in almost every plant, specifically in the wheat, and it affects its productivity worldwide, highlighting the need for the eco-friendly or sustainable approaches to improve the plant resilience. And we also know that rhizobacteria have been proved as a good option to mediate the eco-friendly synthesis of the zinc oxide nanoparticle. So this work specifically use the objectives such as the synthesis and the characterization of the zinc oxide nanoparticles using the Argentine native bacterial strain that were the Azospirillum argentinensis and Bacillus subtilis. Furthermore, we evaluated the effect of the green synthesized zinc oxide nanoparticles on the wheat germination and growth under the normal and water-restricted conditions. Then we compared the results from the both strains and the zinc oxide nanoparticles synthesized from the both strains and its effect on the wheat. Ultimately, we assess the combined effect of the bacterial exudates responsible for the synthesis of zinc oxide nanoparticles on the wheat growth under the drought condition. If you see in the methodology section, first of all, we synthesized the zinc oxide nanoparticles using the both strains separately. Then we did the wheat inoculation with the treatments, and the treatments we used are mentioned in the table. You can see the first one is the water control without any treatment, then the salt control, then the bacterial exudates from both bacterial strains, and then the bacterial exudates along with the zinc oxide nanoparticles from the both strains, and then the wash nanoparticles from respective strains. And we did the Petri plate experiment. First of all, we calculated the radical length, colloidal and germination percentage at 24 hours and 48 hours. Then we did the pot experiment under the control condition, and after the harvesting, we measured the plant height, biomass, etc. So the first, we move toward the results, we found that the Azospirillum argentinensis derived nanoparticles enhance the overall germination rate in comparison with the Bacillus subtilis, while the Bacillus subtilis derived nanoparticles promoted the greater root and shoot elongation. We found that both bacterial exudates and the nanoparticles increased the plant height and biomass under both the conditions that were the normal optimal water supply along with the water limited conditions. And we also found that the combined effect of the bacterial exudates, specifically the Bacillus subtilis and the zinc oxide nanoparticles from the Bacillus subtilis, it exhibited the maximum and the strongest ability in comparison with the Azospirillum argentinensis. You can clearly see the difference between the controlled plants and the plant treated with the different treatments, and the chart exhibiting the comparison between different treatments on the wheat seedlings. Then we also did the zinc oxide nanoparticles characterization based on the scanning electron microscopy and DTS, and we found that the predominant spherical nature of the nanoparticles with size ranging from 38 to 51 nanometer embedded with the bacterial matrices or the bacterial organic substances. You can see in the image section B. And then we also found, based on the EDS, a sharp peak revealing the presence of the zinc. So lastly, I concluded the green synthesized nanoparticles using the argentinensis and Bacillus subtilis is a good option, and they produce stable nano-sized biological machineries for the wheat growth enhancement, specifically in the drought-treated conditions.